All right, we are going to get started with a lesson on linear equations. There are many patterns in math, and remember that math is the science of patterns, and some of those patterns are linear. So let's give ourselves an example. If we're talking about, let's say, two students, let's use Kwesi and Jalen. And let's assume that Kwesi and Jalen, let's say that they babysit. And Kwesi is going to charge $15 an hour. I'm not sure what the going rate is right now for babysitters, but that's how much Kwesi charges. And then Jalen charges $20 up front for DoorDash. So if he babysits, you got to feed him. And then after that, he's going to charge $10 per hour. So that is our scenario. And we are going to try and model what's going on with these two people and their jobs. We're going to try and model that using a linear model, okay? In order to kind of notice what the pattern looks like, we need to make some tables. And we're going to kind of compare these two guys. So we're going to make two tables, and we're going to measure for each person. This will be Kwesi, and this will be Jalen. We're going to measure like what's happening with their money as time moves forward. Okay, so in any situation that's linear, you're going to have two variables. What are variables? Variables represent things that can change in a situation, things that change in a given situation. What do I mean by that? Well, we're not going to say that the price per hour changes. We're not going to say that the $20 DoorDash changes, but there are certain things that can change. Variables represent things that can vary. What can vary? Well, the two things that can vary in this situation are two variables, let's say. Our two variables are money made, and we'll use the letter M to represent that, because you could make different amounts of money based on what? Based on hours that you work. So hours worked, which will be W. All right. And in this situation, so we have two variables, M and W, and we want to know how they impact one another. Well, the truth of the matter is that one of these variables is dependent on the other variable. One of these variables depends on what happens with the other. So one variable is dependent on the other. And if you think about this, you can usually determine which variable is dependent, and we call the other one independent. So one variable is dependent on the other. In this case, let's see. The money that you make is dependent on the amount of hours that you work. You get to essentially choose how many hours you work, but when you choose that, right, based on those hours and the amount that you've set for your salary, you'll be able to calculate how much money you make. So in this case, money is dependent. Money is dependent on time in hours. Now, How does that look in our table? Well, we always kind of keep track of two things, both variables at the same time. For linear equations, again, it's a relationship between two things that change. The first thing, what we said was the hours, or I used a W for that variable. So, okay, we can do that. We'll say W is the hours worked, and M is the money made. Worked and made. And we're going to kind of say that we're measuring how we work in hours. Let's make sure that we keep track of that. Not minutes. In this case, we're measuring in hours. And then the money that we make is going to be, let's say, in dollars. So we have to be consistent in our unit so that we know, so that we can compare similar things, right? We don't want to compare hours. You know, if we said, okay, Kwesi worked 2 hours, and then we were measuring minutes, and we said that Jalen worked 2 minutes, and we didn't know what we were comparing, we'd lose track of kind of the situation. So we're going to say hours worked. We're going to give ourselves, let's see what happens when we work 0 hours, or 1, or 2, or 3, or 4. These are all hours that you worked. We can't work negative hours. We're not going to pay attention to negative numbers in this case. Again, we're going to look at Jalen, what happens with his money when he works 0 hours, or 1, or 2, or 3, or 4. Okay, and let's kind of examine what's happening with Kwesi. If Kwesi works 0 hours, and we know that he makes $15 an hour, in the first, or we should say, if he doesn't work, he makes no money. All right, so we're saying with 0 hours worked, $0 are made. What happens if he works 1 hour? If he works 1 hour, he makes $15. And we can write it just as 15. We're not dealing with change in this scenario. What about if he works 2? If he works 2 hours, he is going to make $30, right? He works another hour at 15. If he works 3, he's going to make 45. And if he works 4 hours, he's going to make $60. So I kind of want to examine what's going on here. Let's take a look at this. This $15, another way you could consider it is you could really say that you just have 115. For $30, you could say you have 15 plus 15. For $45, you could say you have 15 plus 15 plus 15 plus 15. And for $60, you could say you do this 4 times. 15 plus 15 plus 15. Oops, did I do that wrong? That's a mistake. This should only have 3 15s. This should have 4. All right, there's one mistake. I'll keep track. So notice that it's counting by 15s, right? And what is multiplication? Multiplication is repeated addition of equal groups. That's what multiplication is. So now I'm going to write these same things, except for this time I'm going to write it kind of using multiplication. So we're going to say this is 15 times 1. This here is 15 times 2. This here is 15 times 3. And this last one is 15 times 4. And if you're noticing the pattern, this one up top we could now say is 15 times 0. Notice what's happening in this pattern. You have 0, 1, 2, 3, and 4. And those numbers line up perfectly with these numbers on the other side. 4, 3, 2, 1, and 0. So whatever this hours worked number is, that's what's getting multiplied by 15. What if we wanted to pick a random number of hours worked? What if we didn't want to assign a specific value to hours worked, and we just wanted to say, okay, let's say that you work W hours. How would we calculate dollars or represent that in this table? Well, in this table, we said that you're taking the number 15 and you're always multiplying it by the number of hours that you worked. So this would be 15 times W. Whatever W is for hours, the amount of dollars that you work is going to be hours times 15. okay, which is a pretty cool pattern. Now we're representing it not with specifics, but in general terms. We could also write this as just, 15W with no product operator in between. So if you see this right here with nothing in between, it actually means multiplication. When you don't see the operator, it means multiplication. All right, so let's keep going. We could actually write a little formula for Quessy that represents the pattern based on what we know in the table. We know that Quessy's money that he makes, right, because is going to be equal to this right here. So we're taking this money, we're saying, okay, the money that he makes is always going to be equal to 15W. And that right there is called a linear equation. We've taken our two variables and we've represented the pattern of what's going on in Quessy's babysitting world using variables. And we like this because it's general. That means I could use, if I wanted to predict how much money that Quessy would make if he worked 10 hours, I would take 10 and multiply it by 15 and I get $150 and I'm good. This equation helps me to calculate things quickly. It's a shortcut equation, so we don't have to add up 15 10 times, right? We know the relationship between the two variables that are changing. And this is called a linear relationship. There's a reason why it's called a linear relationship. We'll talk about that in a minute. But let's take a look at Jaden's scenario. So Jaden, we said, works, let's say, what are we saying here? Well, if Jaden shows up to the door, sorry, not Jaden, Jalen, I can't read. If Jalen shows up at the door and the babysitter, the family's like, oh, we don't need you tonight. We realized, kids are sick. They're still going to hand him the $20 DoorDash card just for showing up. So we're going to give Jaden, we're going to say, even if he works $0, he gets that $20 added on. This is a different scenario than Quessy. All right, so we've got 0 hours worked, $20 made. That's nice. But he's charging less per hour. So let's see what happens over time as he works. Well, if he works 1 hour, right, he makes how much per hour? He makes $10 per hour plus that extra 20. You got to keep track because we're saying if he only works for an hour, how much does he walk away with? Well, he'll walk away with $30. But how did I get that? Well, we said the $10 that he makes in that hour plus the $20 that he kind of gets at the beginning. All right. How about if he works 2 hours? If he works 2 hours, he's going to make $40. How did I get that? Well, he worked for 2 hours, each at $10, and then he gets that $20 added on. If he works for 3 hours, he's going to make $50. You're starting to see the pattern. It's 10 plus 10 plus 10 plus 20. And then this $60 is what he's going to make, at 4 hours. Here we go. 10 plus 10 plus 10 plus 10 plus 20. There we go. So do you see the pattern of what's happening here? We've got two different things going on. We've got the 10 pattern, and we've got this $20 every time that kind of gets added on. If you're keeping track of how much money you make, you add up all the hours that you worked, $10 for each hour, plus that extra $20. Well, what does this look like? If we say, okay, I want to know in general, if I work W hours, what's going to happen? How much money am I going to make? Well, in this case, it's the same as in the other case. However many hours you work, that's what you're multiplying by 10, right? So if we have 2 hours worked, it's 2 tens. 3 hours worked is 3 tens. 4 hours worked is 4 tens. W hours worked is going to be 10 times W. Okay? For every hour that you work, you're going to multiply that by 10. But that's not the full picture of what's going on with Jalen, because he also gets that $20 that kind of gets tacked on extra, right? Like a little tip or something. So the hours that Jaden worked times $10 plus 20 extra is going to be how much money he makes. Let's see if we can write a formula for that. Let's see, we've got money that he makes is equal to 10W plus 20. There is our equation for Jalen. So what we've just done is created two equations, two linear equations that represent these patterns of money and dollars made. All right, so now what? We're gonna take this a little step further, because I told you that there were graphs. Well, I don't know if I told you this. I told you that there were linear patterns, that these were linear. So I'm going to kind of draw a little graph that represents, or that we're kind of scaling. Let's see here. Let's do this. So this. Give ourselves a nice graph here. One more time. All right, I am going to create a graph, and when I'm drawing a graph, when I'm drawing this kind of place to measure or show graphically what's happening with my patterns, I need to decide where my variables go. There are actually two ways to measure on a graph. What I'm doing with this horizontal line is measuring the independent variable. The independent variable goes on this horizontal line, and we call this the x-axis. So it's kind of the x variable. But in this particular case, it's representing hours worked. So this horizontal line is going to measure how hours worked, and then simultaneously at the same time, somehow we're going to measure two things at the same time. This vertical line is going to represent the dependent variable. And in our situation, well, the dependent variable is always represented with y, so we call this the y-axis. And in our example, the dependent variable is going to be money made. Money made in dollars, right? Okay, so I'm going to create equal intervals. It doesn't matter how much I count by, but the spaces between them have to be the same. Like I can't start counting by 2s and then end counting by 5s. I'm going to count, I think I'm going to count by 10s here. I'm going to go 10. Does this keep happening? I'm going to count by 10, 20, 30, 40, 50, 60, 70, 80, 90. All right, and those are dollars made. See, I'm counting by 10s each time. You can do that. Now you got to start at 0 on the independent axis as well. And we're going to count by 1s because that's kind of how we were measuring. That's kind of how we were measuring hours. We're counting kind of by 1 hour at a time. If you work 1 hour, 2 hours, or 3 hours. And we're going to have 1, 2, 3, 4, 5, 6. Okay, so this is our graph that's going to represent both of these kids and how they're babysitting. Now let's remember what we're doing here when it comes to our tables. I'm just going to rewrite our tables real quick. You probably have these in your notes already, but I'm going to include them. We're going to say, okay, hours worked, money made. Hours worked, money made. I probably could have picked a better variable instead of W. I probably could have said like H for hours. That would have been fine. Doesn't matter what you call it as long as you stay consistent. So this is again 0, 0. This is Kwesi. This is Jalen. Kwesi 0, 0, 1, 15, 2, 30, 3, 45, and 4, 60. Could we keep going? 5, 75. All right, that's a lot of points. Jalen's was 0, 20, 1, 30, 2, 40, 3, 50, and 4. 60, we could keep going. 5, 70. So let's use red for Quessy, and we're going to plot his points. Watch, something really cool happens. So 0, 0. This is actually a point, 0, 0. That's what those two things look like when we put them together as a point. And this would be 115, 230, 345, 460, and 575. These are all points. And we're going to graph them on this graph. If you know about graphing, we know that we're measuring the x first, the x variable first, and then the y variable, or in this case, w and m. So we're going to go 0 in the x direction, which is the horizontal axis, and then we're going to go 0 in the y direction. And there's a location that represents that. That's this location. If we want to graph 115, we have to go over to 1 and then up 15, and that's kind of somewhere in the middle of 0. Wait, no, that's not right. It's got to be past 10. Oh man, I'm at 2 mistakes. What are we doing? 1, we've got to go to 15. So 15 would be halfway in between 10 and 20, so maybe right there. And then 2, we're going to go to 30, so we're going to go up here. 3, we're going to go to 45, which is there. 4, we're going to go to 60, which is there. And 5, we're going to go to 75, which is right there. So when we talked about patterns, you can see that this is not a coincidence, that these points are lining up in a straight line. And we use the word linear to kind of represent what a straight line is. Let's make my points a little bit bigger so that they kind of show up here on the line. There we go. So you can see, right, that those are kind of marking hours worked and how much money made. At the same time, they're measuring two things. And this is Quessy's line. But let's not forget about Jalen. So when Jalen works, and his numbers and his points are going to look something like this: 0, 20, 130. And again, we're writing those two measurements together, and each of these partners are considered a point. A coordinate is another way we say that. 460. So these are coordinates. 570. We've got the list here. And what are we doing? We're saying that, again, this is kind of your x measurement that comes first, and then your y, and we call it plotting, but we're finding the place on the graph that represents 0, 20. Well, 0, 20 means go over in the independent axis 0 and then go up 20. So kind of right here. And then over 1 up 30 represents kind of what happens in the first hour. Do you see how we did that? We went over 1 and up 30 and put the point down. Over 2 up 40, just kind of right here. Over 3 up 50, which is right here. And over 4 up 60. Well, that's the same point. Those two things are right on top of each other. And that's significant. And then over 5, we're going to say, what are we up? Over 5 up 70. This was supposed to be 75, and then this is supposed to be 70. So it's not exactly on the line. It's kind of next to the line. And then if we connected the dots for these, I don't know, maybe something like this. There we go. Okay, and so this is Jalen's line. And if you'll notice, both of these scenarios are what we call linear patterns. Both scenarios, both cases, let's say, are linear. the pattern is linear. What does that mean? Well, it means that we essentially, a way to maybe kind of explain this, a working definition would be when we see the measurements on a graph, when we see their measurements on the graph, they line up in a straight line. That doesn't always happen. They line up in a straight line. But in this case, it does happen, and that's a linear pattern, and we can represent it. Again, we used two different equations. One of these equations was Quessie's, which we said the money he makes is going to be $15 times the hours that he worked, and the other one is Jalen, which says the money that he makes is going to be equal to $10 for every hour that he works, plus that $20 thrown on at the end. And then for those of you curious, you should notice something. You should notice that there is a point where they kind of make the same amount of money and they work the same amount of hours, and we call this the intersection of the line. So we might add on this last and final thought. The intersection of the lines is where Quessie and Jalen work the same number of hours, and end up with the same money and make the same money. And sometimes we like to label this point right here, and in this case we're calling this point of intersection, we call it, but it is at 4:60. So that's 4 hours, $60. All right, so this is a good introduction conceptually, kind of what's going on with linear patterns.